Right. So, sharing the right thing. Everyone see my slides? Yeah, sounds good. Cool. So, hey everyone, my name's Steve Lorello, and I'm the .NET Developer Advocate at Vonage. And I'm here to talk to you a little bit about Blazor today. So the topic of this talk, front ends without JavaScript, underlines kind of what I've taken away from Blazor thus far. So I've worked up and down the stack across lots of different technologies, from the lowest level FPGA code to C and Python, but I've honestly never felt quite as at home as I feel in the .NET stack. So that's actually why Blazor is so darn exciting to me. See, I've never really seen myself as a front-end guru. I can structure HTML just fine. I can stumble together some style sheets when I need to, but the freewheeling, ever-evolving, almost manic nature of JavaScript and its child frameworks has always made it difficult for me to feel truly comfortable working in front ends. And the really neat thing about Blazor, to my mind at least, is that it allows you to do much of everything that you would need to do in a front end without leaving our .NET comfort zone. So let's talk a little bit about the agenda of what we're going to talk about today. So we're going to start off with a brief overview of what Blazor is. It'll talk a bit about how it's structured. Then we're going to talk about the different flavors of Blazor. Primarily, we're going to be talking about Blazor Server and Blazor WebAssembly. Then we'll start looking more deeply into Blazor Server. We'll start off by looking at a bare bones application, the one that you actually get out of the box whenever you spin up a Blazor Server app with Visual Studio. And then we'll start looking at using these constructs in Blazor Server called services, and how you can leverage them to actually sort of combine your front end and back end logic really easily and relatively safely. And after we've looked at Blazor Server, we're going to start talking about Blazor WebAssembly, which to my mind is actually where Blazor starts to get really compelling. So we're legitimately going to be able to run .NET code in our browser. We'll start again by looking at some bare bone projects, the ones you get out of the box with Visual Studio. And then we're going to move on to some more interesting integrations where you can start mixing Blazor WebAssembly with actually .NET Core hosted servers. And then we'll be looking at combining Blazor with other canonical .NET frameworks such as SignalR and the Entity framework, and build some reactive apps that can persist data fairly easily. And we'll see just how truly well integrated Blazor is with the entire .NET ecosystem. And finally, we'll be looking at some cool examples. So let's start off by asking a question. What is Blazor? So Blazor is a .NET single-page app framework for building web interfaces. So if you've taken anything away from this so far, it's probably that Blazor allows you to more or less completely forego JavaScript when you're building your front ends. We get to preserve all the nice type safety and syntax of any other C# app that we might be writing while building cool reactive front ends. In the case of Blazor Server, you can technically even share application logic between the server and the client without breaching the front end and back end boundary. So this leads to a great amount of reusability for even UI components, which are the building blocks of Blazor. And there's actually a budding component marketplace that allows you to reuse these components between different applications. And that lets you do all sorts of things. So this is all done without any form of transpilation. So if you're familiar with the term transpilation, it's essentially compiling one language into another. So traditionally, you would compile like TypeScript or CoffeeScript into JavaScript. And Blazor doesn't actually have any need to do that. And we'll talk a little bit more about how Blazor is able to do that a little bit later on. But we really are going to be running all of our UI logic in .NET. So in addition to pulling in third-party components, you can pull in third-party components, and you could leverage actually the classic third-party libraries like any other .NET app that you might be writing from the Blazor runtime. And this enables you to literally write all of your code as if you were writing any other .NET app, but you get all the UI elements on top of it. So let's talk really briefly about components. So they're both the building blocks and the backbone of Blazor. Components are flexible UI elements that manage all the rendering logic for Blazor. So if you've used MVC before, you're probably used to using Razor syntax and CSHTML files. Those are what compose the front end of ASP.NET MVC. So Blazor doesn't actually use CSHTML, and it doesn't use the precise Razor syntax that you're probably used to if you've used MVC before. It uses a newer version of the Razor syntax, and all the components and pages are actually written in .razor files. So components can be shared between projects, and they can be pulled from all sorts of places, including, of course, like NuGet. You can pull components from. So since we're talking about Blazor, I think I'd be remiss if I didn't spend at least a minute talking about SignalR. So SignalR is actually going to act as the Sino to make everything that we're about to do and discuss possible. So if you're not familiar with SignalR, think of a hub and spoke system. So your web clients in this diagram, the little white dots surrounding the hub, feed into and get fed from the hubs in SignalR. So if you've ever studied mass distribution, like the mail or parcel delivery works, they're conceptually very similar to how SignalR works with the hub and spoke kind of system. Ordinarily, your applications will send an initial request to the server and pull back a web page. The server will respond, and until your client comes back and asks for an update or a new page, the client's not going to get any updates from the server, and the data on it can become stale. And that's actually exactly the problem that SignalR solves. So SignalR sets up these bidirectional connections with its various clients and pulls input from and broadcasts output to all of its clients. SignalR will dynamically choose between, there's three paradigms it can use: long polling, server-side events, and WebSockets. And it'll choose the correct one based on your network conditions. Its preference is going to be WebSockets because WebSockets are kind of the best for this circumstance, but it can also, it could fall back to server-side events and long polling. And regardless of what protocol it uses, this ability to actually maintain these persistent connections with the servers is going to be really important for building Blazor applications. And in a little bit, when we start talking about some of the other cool integrations you can build Blazor, I'm going to be using SignalR quite a bit, actually outside of the Blazor framework. So now that we've spoken a bit about what Blazor is and a little bit about SignalR, let's discuss how Blazor is able to run UI code in .NET without any type of transpilation. So to me, this is actually one of the really neat things about Blazor. As other languages that have sought to supplant JavaScript, like TypeScript or CoffeeScript, they need to transpile into JavaScript, whereas Blazor doesn't have the need to do that. So there's currently two primary flavors of Blazor: Blazor Server and Blazor WebAssembly. There's talk about a forthcoming Blazor hybrid, which I think it's going to essentially enable you to build these apps for your phones too. But right now, there's these two: Blazor Server, Blazor WebAssembly. So we'll start off by talking about Blazor Server, which, as the name suggests, is the flavor of Blazor that runs primarily on the server side. And this diagram here kind of describes to you largely how Blazor Server behaves. So if you study this diagram, you'll see what I mean by essentially your client UI code can run like server UI code. You see, the browser sort of acts as a thin client to your Blazor Server application. The Blazor Server app runs in .NET Core and executes all the UI code on the server side. Hence the name Blazor Server. So Blazor Server then leverages SignalR to take input from the browser and send instructions to manipulate the DOM to the browser. So as you can see here, all the logic, all your C# code runs server side. So in this case, you don't have to actually worry about the client server boundaries you'd ordinarily have to consider otherwise. You can run things like database queries and send API requests, do all sorts of things that you might not otherwise want to do from a client-side application because of security concerns. That said, it's still my opinion that you probably should maintain that level of separation. If for no other reason, you might want the flexibility to switch down the line. So all you need to do to create a Blazor Server app is to execute this command in your CLI. So .NET new Blazor, then pass in the name flag and the name of a application you'd like to create. In this case, it's going to create a Blazor Server Hello World app. So that actually builds, this scaffolds like this directory structure. It's just like a really basic like Hello World app kind of thing. They include three things in it. They include an index page, which kind of just asks you to fill out a survey about Blazor. This fetch data page, which pulls back some static data from a weather service, and a counter page. And this counter page actually I like to use to illustrate kind of how Blazor Server operates because it's pretty digestible. So if you look at this counter.razor file, you'll see this code in here. So this component is built, like I said, in that scaffolding. And I like to use it because it's pretty digestible. So the @ symbol is probably something you're familiar with if you've used ASP.NET MVC before. It's the traditional transition symbol from HTML to C#. In this case, its page directive is declaring that this component can handle its own requests directly and is in fact its own page. So the code directive here is Blazor specific. This is where you can define all the fields, properties, and methods for your component. Case in point, you can see the current count field is being accessed by the component after being declared inside of the code directive. So these items are bound together. So whenever the current count changes, it automatically updates the current count value in the DOM. So similarly, the onClick directive binds the increment count method to the onClick event of the button. So let me just illustrate this real quick before we move on. Did someone ask a question in the chat? Blazor Server.
Yeah, it was answered. Thank you.
Okay, cool. Yeah, so let me just switch. Sorry, I have a really wide screen, so I can't just share a whole screen, or else it would look really wacky. So this is that page that I was talking about, that counter page rendering. So now, if I refresh this thing, so by the way, like all the CSS in here, this is actually kind of provided by, they give you like a CSS file that goes along with Blazor, and so I'm not doing any of the artwork here. It's all them. So if you go into your network tools, you'll see like normal stuff that you'd be pulling back, like JavaScript files and HTML files. But you also see this WebSocket connection get upgraded. And this WebSocket connection, if you look at it, it's on the 101 protocol, so it did a switch after a get. And if you look at the messaging here, this is all the messages that's actually going back and forth between the browser and being received back by the browser from your web server. So as I click the increment counter button, you'll actually see these messages fly by as the event actually happens on the browser, gets kicked up to the server, and then the server responds back with whatever the UI update needs to happen. So, I mean, I think that's a pretty decent illustration of kind of how Blazor Server works. I'm going to switch back over to my slides. So now that we kind of talked about just the basics of how Blazor Server works, we're going to talk a little about these neat little constructs that Blazor Server provides called services. Now, if you've used Angular before, they're conceptually very similar to Angular services in that they essentially stand as injectable singletons that you can use throughout your components. I'm sure there's other instances of these things being used elsewhere, but like that's the one that quickly comes to mind when I'm thinking about front ends. Sorry, I think my dog is kind of up and wandering around. So we're going to build a service to actually send WhatsApp messages from our Blazor Server app. Now, this WhatsApp service is going to use our messages API, which is an API that requires a private key. So it's essentially a secret that you don't want bleeding out from your back end to your front end. But with the way Blazor Server is architected, um, the way it's separated, we're going to be able to manage to do this without breaking any kind of API security, secret security, and without having to actually go to like a web controller somewhere. So I'll start out by adding our client library. It's called nexmo.c#.client. Vonage bought out a company that I used to work for called Nexmo that provides these APIs. And we're going to add that to our Blazor Server Hello World app project. And this contains most of the logic that I'll need to do to run this. I'll also add to my app settings file my application ID and my application's private key. Now, like I said, that private key is secret and shouldn't be leaked out. So I'll create this WhatsApp service. So we're going to create this WhatsApp service, and it's going to look like kind of any other API controller that you might have seen before, except it's not going to have any kind of routing information, post information, but it's going to use dependency injection, and it's going to use those same dependency injection hooks that you're used to using. But it doesn't need to be accessed over HTTP because Blazor Server is running server side is kind of like a thick client. It can be accessed directly through the runtime. Now, in this instance, I'm injecting a configuration object, which, like I said in the last bit, I'm adding to my app settings file a key and a application ID, which are like the secret API secrets that I need to actually send the message. So now that we have that configuration injected into our service, we can pretty easily send a WhatsApp message. This is kind of all you need to do it. Message API allows you to send WhatsApp, Viber, SMS, Facebook Messenger, MMS. So we need to specify the type of message that we want to create the message, provide the text, and send the message. So I'll pull those keys out. Like I said, this is coming from these are secrets that are coming out of a configuration file. And so from here, I'll just create this credentials object, which I'll use to interact with our API. Then I'll create this message, which essentially takes text, and I specify that it's using the WhatsApp channel. That's what the type is in the to and the from. Like you could supplant that pretty easily with SMS, MMS, Facebook Messenger, Viber, like I said earlier. And finally, I can send it. Well, actually, I need to create a URI. So the URI is going to point at the sandbox, which I like to use because it's free and easy to set up. And then I just send it I send a post request to that URI with that request object and the credentials that I created before. Now just respond with the message UUID. So next, in this startup file, I actually need to configure the middleware. And so that's pretty easy to do to inject these services. So you'll see like right above the line that I'm adding, they have that weather forecast service. And that was that like scaffolded weather forecast service that they use in the fetch data field and fetch data thing in here. It's essentially the same thing. You're just injecting that service into the startup file when you're configuring the services. So with the services created and added to our application, the next thing we need to do is to provide it to our component. So we're going to open up, I'm just going to use the index.razor file. And this is like the main landing page for the Blazor app. So when it starts up, it goes over to this file. And we're going to throw these three directives on the top of it. So that first directive is the page directive, which we spoke about already. So we're going to ignore that. The second is like kind of any other using statement that you used in C#, except you'll notice it doesn't actually have a semicolon at the end of it. And the third is going to take that singleton service, and it's going to inject it into our component so that we can use it. So this piece of code here is just basic kind of like HTML razor, right? It creates this, I'm calling it a pseudo form, but like essentially has a to, from, and text field, which are the three input fields that we need for our service call. And you'll notice how it uses the bind directive for the to, from, and text, and also And that's actually binding those fields to our component code. And I'm about to define that in here. So like I said, all those fields and that send WhatsApp message that's like tied to the button back here, that onClick method, are all defined kind of in the code segment. So now I have all those things to access, and I just take those and yeah, send the message, and that's pretty much all I got to do. So just show this. So I'm going to go back into the developer tools. We'll actually see, I need to remember what the WhatsApp number I need to send from is. It is just say hello. This is Blazor Server. You'll see in here, those messages actually go up. If you don't even know which one it is, it's probably this one. And then here, my Blazor in my WhatsApp, I actually received the message. It's pretty neat. So, stop presenting. Cool. So now that we've looked at Blazor Server, we're going to talk about the one I actually like better, which is Blazor WebAssembly. So before we start diving into any kind of code for Blazor WebAssembly, let's ask a question. How the heck can we run .NET code in our browser? And well, the answer is actually WebAssembly. So WebAssembly is an open standard that defines portable binary code that can be ported between different web browsers. Now think of this as its own form of assembly language, except instead of running on like an Intel or AMD processor, it's running on top of a web browser. So WebAssembly is, in fact, the fourth language that runs natively in a browser, along with HTML, CSS, and JavaScript. So the trick here is that Blazor compiles into WebAssembly, allowing it to be downloaded and executed in the browser. So if you look at the diagram on the right here, you'll see your browser's UI thread is actually where your Blazor's code is running. So a couple of downsides to this is you still have to be cognizant of the client server divide. Download package is a little bit bigger. Like I don't think it was more than a couple dozen kilobytes for the Blazor server app that I just work with, but the Blazor WASM is like, I think 3.4, and if you strip out all like the extra CSS and stuff, it could be like 2.8 meg. So it's a little bit bigger. You also are on the UI thread, so you need to make sure you're writing code asynchronously and cleanly. But the upside is that you don't have to run like a farm of thick clients with your like you would with Blazor server. And also because it's running natively, there's no latency between what's happening in the back end and what's happening in the front end, because you don't have to maintain that constant SignalR connection back to your server. So it's creating a Blazor WebAssembly app. It's very similar to creating a Blazor server app. It's .NET new, but instead of Blazor, it's Blazor WASM, and you pass in the -n, and Blazor WASM Hello World is what I call this first app. So this time it scaffolds something that looks a little bit different. If you looked at the scaffolding from the Blazor server app, you notice a couple of key differences here. So this weather.json file wasn't there in the last instance. Instead, it called that service class that I mentioned when I was talking about Blazor server. And the reason it's using a JSON file here is because there's no server code running. So it has to rely on the static resource to actually display anything. So if you look at the counter and the index file, they operate exactly the same, but because of the way that the Blazor WebAssembly is architected, this project needs to necessarily run without any like server code. So this can be really useful if your code doesn't actually need the internet at all to run. Like, I mean, like obviously you need the internet to get the Blazor WebAssembly app, but if you didn't need the internet otherwise, you could legitimately serve up a WebAssembly page, and then your user can put their device in airplane mode, and they can be on their way. But let's look at something a little bit more realistic. So this command, unlike the other .NET New command, passes in this hosted flag, which is the -ho. And that tells the CLI to scaffold a .NET Core hosted Blazor WebAssembly project. So this produces something that, to my mind at least, is much more useful. There's 3 projects that it generates. So the first is the client app. Now this is exactly the same app that we produced last time without the hosted flag, but with a couple of key differences. So that weather data JSON file is not in the www root anymore. And it's not there anymore because the server half of this has it. So in the server half, that JSON file has been replaced by an old friend of any ASP.NET developer, an API controller. Now the API controller in this toy example is just piping back some canned response. So it's essentially as dynamic as that static JSON file that we had earlier. But now we actually have some server code that's serving up our data somewhat dynamically. And so the last project is the shared project. And this is usually the like model data that you want to share between your host and your client. So now that we have a hosted Blazor WebAssembly app up and running, let's do something interesting with it. So we're gonna reverse what we did last time, and we're gonna actually receive WhatsApp messages. And I'm gonna be using the Entity Framework for this. So the first thing we need to do is to actually build a model to work off of. I'm going to use a POCO that I'm going to use Entity to essentially store. So like I said, I'm going to use the Entity Framework to store these messages in an SQLite database. And we're going to be using that .NET Core hosted server to perform the read and write operations on that model. So we're also going to, to the shared project, we're going to add system.componentModel.annotations, and that's going to let us essentially tag this POCO here with an ID, which is the message ID for the inbound messages. Now we're going to annotate with the key attribute, and then we're going to use the to, from, and text property as the actual data to store what we're getting from these inbound messages. That's all we really need from the perspective of this POCO. So now in the server project, we're going to create this WhatsApp context object. And that WhatsApp context object is going to have this database set that stores all the messages in it. And it's also going to have on configuring method, which essentially creates our SQLite database, which is the Vonage WhatsApp DB. Then we'll run a command to create the initial migration, and then run an update to create the database for us. .NET EF is like a plugin to the .NET CLI that you can, I think it's like .NET install Entity Framework or something like that, and you'll get this EF migrate, this Entity Framework, plugin, which allows you to run all the migrations and do all the updates fairly easily. So now we need to register that context object with our services. So similarly to like the way we injected the service last time, we're going to add this database context object in here. And that's going to allow us to actually read stuff from our controller, which we're about to make. So now with that context set up and our model created, we're going to actually move on to building our controller. So we're going to build this controller, which is just an API controller. It's going to handle the inbound messages for us. It also allows us to handle all the read and write operations from the inbound messages and the read operations from our Blazor WebAssembly front end. So this method actually handles the inbound WhatsApp message from Vonage. It parses the webhook that we're receiving. So we're receiving these on a webhook, which if you're not familiar with, is like essentially you leave an HTTP endpoint open on your server, and it allows like a service like us to call into you with like a message, for example. And then we're gonna receive that webhook, parse it into a J object, and then from that J object construct that WhatsApp message that we created in the model and that we're actually storing in the database. Then we're going to write the changes out to the database. On Vonage side, so like if you have your Vonage account up and running, you can go in and on your dashboard set up the webhook. So in this case, I'm using nrock, which if you're not familiar with is essentially a piece of software that lets you tell your local host out to like the public internet. So I can expose over the public internet HTTP ports. So this is really helpful when you need to test stuff like this, like inbound webhooks. So yeah, I just go in and I register the webhooks with the Vonage dashboard and we're good to go. So on the other end, so now that we've received the messages into our server, we actually need to grab them from the WebAssembly app. And so we're just going to create this route in here that just get messages. It's going to just read the first 10 messages off of the database. It's not going to get creative, and it's going to return back to our front end. Okay, so now let's actually do the Blazor part of this. So we're going to set up the front end, and that's actually like, in my opinion at least, it's the easiest part of writing this. And mind you, I'm a back-end developer mostly, so it's pretty cool that like the front end's actually relatively straightforward. So this bit here is similar to the other like setup parts we looked at before. We're going to do it again in the index.racer file. And we're going to add that shared project as a dependency here so that we can get that contract data and we know what it looks like. And then we're going to inject an HTTP client so that we can, as you might have guessed, handle the HTTP request to our backend. So then we're just going to throw this table in here. So the table is just going to have 4 columns, message ID, from, to, and text. And then there's this for each loop here, which takes each message in the messages collection that we're about to define and creates a new table row in here with the 4 outputs from it. And the final bit here is to add that messages list into our code directive, and then we're going to actually grab the messages off our server. So as you can see here, the act of getting the stuff from our server, this like one line of code down here, the underscore messages equals await HTTP client dot get from JSON async, is actually like super simple to do. I mean, it's like if you're used to making like AJAX requests and then like parsing things in JavaScript, it's a little bit more complicated than this. But like this is like legitimately a one-liner. We have all of our contract information, which is our list of messages, and we just go to that endpoint that we defined and pull back that data and just store it in here. So I mean, like that's cool to me. I don't know if anybody else thinks that's really particularly interesting, but I mean, like I think it's a really neat, like that it's that simple to make these web requests from Blazor. It's like one of the really compelling things to me, and one of the things that actually I'm like super excited about is just how easy it is to do these requests from Blazor runtime. So now let me just demo that real quick before I move on. So I need to actually start up this app quick. Here we go.
This is great. Thank you, Stephen.
Cool. I mean, it's really exciting stuff, and I'm going to be totally honest with you. I was really skeptical about Blazor for like the first year that they were pushing it really hard, and then like I tried it, and I'm like, wow, this is like really easy to use. It's like it's super exciting, really. It really is.
Yeah, no doubt.
So let me just share this window with you. So like you can see I have a message in here already, but like I'm just going to send another one real quick. So I'm sending it through WhatsApp. And if I go into here and I refresh, you see hello Steve from WhatsApp, which is the message I just sent. All right. Chrome tab. Okay, so that was pretty cool. We essentially built a front end using some basic CRUD and WebAssembly, and we ran our app completely in C# in our browser. But I actually don't think that's that interesting because it's not really reactive. So I'm going to spice things up a bit and bring a little life to Blazor WebAssembly with SignalR. And I'm going to be doing something which is a little bit ambitious, but I think it's going to really show off the seamlessness of the integration of the client-side Blazor and server-side ASP.NET. And I'm actually going to build a real-time speech translator that'll take the input from the dialed-in phone call and push the translation out to our front end. And because I'm speaking at NCR Delhi, the translation is going to be from English into Hindi. So if the translation's off, you can blame Azure Cognitive Services. Don't blame me. So we're going to start the same way we started our last project, except we're going to name it Speech Translator Blazor. So for this demo, we're going to have a user dial into a service via standard PSTN line. When that dial-in is received, we're going to have some logic that is going to tell it to forward us a WebSocket connection to pipe all the audio from the PSTN call into our server. Then we're going to take that audio from our call and we're going to pipe it up to Azure's Cognitive Services using the Microsoft Speech SDK. And when we get the output from the Speech SDK, we're going to take that translation and push it down to our front end over SignalR. And finally, we're going to display it to our users. Also, we're going to actually take the translated text and we're going to use a synthesizer to convert that translated text back into audio. And then we're going to push that audio back over the WebSocket to the person who dialed in so that they can hear the translation. So we're going to start off in the shared class again. I think it's nice to start off in the shared class because it's good to kind of define your contract data. And we're going to create this POCO called translation. And that's going to hold a UUID, which is the unique identifier of the call. It's going to hold the text of the translation. It's going to hold the language that's being spoken and the language that's being translated to. And those are both going to be in BCP 47 format. So next, we're going to create this translation hub. So we spoke earlier about SignalR and hubs. So this is our SignalR hub, essentially, that we're going to be receiving and broadcasting everything down through. So this hub doesn't actually need to have any logic other than the fact that it's implementing a hub. So it's a super simple piece of code. Now we actually need to, now that we have the hub and the model data kind of defined, we need to configure the middleware for our app. So part of this is going to be, this part is going to be a bit long. So I'm going to do this in two parts. The first part is a SignalR part. So we need to actually map our hub in the configure function using endpoints.maphub, hubs.translation hub. That's the generic type. And then I'm going to pass a route, which is /translation hub. And then in the configure services section, I need to actually add SignalR as a service. So I go services.add SignalR. So next, we need to actually configure the WebSockets themselves. So in here, we're enabling the WebSockets in the middleware. We're telling them to expect a buffer of size 640 bytes. So we're going to be receiving an audio codec that's a 16 kilohertz linear PCM. And so that's going to be the message size, 640 bytes that we're looking at for each sample. With that done, we're going to have to manually map an endpoint from the use endpoint delegate. And this is a bit weird in ASP.NET. Normally, you just do it when you're configuring your other endpoint, when you're configuring other stuff. But because the way that Blazor WebAssembly is hosted at the root of the server-side's app, we actually explicitly need to define this route in here. So we define this route as /WS and pass it an async delegate to handle the upgrade. So we need to pull the SignalR hub that we just set up our application services with so that it can actually be used by our translator. So that's what this line of code is doing. It's actually pulling that hub context out of the list of services for our app. Then we'll actually create the WebSocket connection, which is going to be what's upgrading. So right now, like up to this point, this is actually get, and this is going to upgrade that connection to a WebSocket. And that's going to let us run all of our translator code. And finally, we're going to be using this translation engine class. We're going to construct it and pass it the configuration for our app, the hub, the HTTP context from this request, and the WebSocket. And we're going to talk in a little bit about how this translation engine kind of works. But first, we're going to actually talk about the voice controller. So the voice controller is actually what's going to handle the inbound call from the user. And this is going to handle it through a webhook similar to what we were just talking about before with webhooks for the inbound messages. But in this case, you're just going to have one webhook, which is answer. And that's going to be routed through /webhooks/answer. So this webhooks, when it's received, is going to actually construct something called an NCCO, which stands for Next Mode Call Control Object. It's just a JSON object that defines some useful stuff for us, and it kind of tells Vonage how to handle the inbound call. So in this case, we're going to create this WebSocket endpoint and have it connect to that endpoint. So the first thing we need to do is add the URI here. So notice how I'm using the host string from the request in here. And because NROC, which is the thing I'm using to tunnel to the public internet, doesn't handle secured WebSockets particularly well, I like to just use the default of using regular WS, which is an unsecured WebSocket for these demos. I'd always recommend using the secure version in your production app, but because of the way NROC is, you like to use the unsecured ones. And notice how that's actually pointing to that same /WS route that we just defined in the startup file. So the content type is going to define the audio data and how that's structured. Like I said, this is going to be 16 kilohertz linear PCM. We can support either 8 or 16 kilohertz, but I find with when you're doing things that require cognitive services like translation and transcription, it's probably just better to use the higher kilohertz because it processes a little bit better. And then finally, I'm going to pass in that translation object into the header of this WebSocket endpoint. And the reason I'm putting it in the header is because the data that's in the header is going to be the first message that's received on the WebSocket when it's actually receiving the message. So in this case, I'm passing in the unique identifier of the call, the language spoken, which is English because I'm going to be speaking, the language that it's translating to, so in this case, Hindi, and then it's actually going to put this endpoint into an NCCO, and it's going to turn that endpoint or turn that NCCO into a JSON string and return that back to Vonage, and Vonage will know how to process it. So now let's talk a little bit about the translation engine. Now, the translation engine, I will share all these repos with you later. And so I'm not going to go through everything that happens in the translation class. I'm probably going to go through a good 60 or 70% of it, which I think it highlights. So this is the beginning of that receive audio on WebSocket method that I spoke to earlier. So at this point, we've upgraded to a WebSocket. And so we'll grab that first message off the WebSocket and store it in a byte array. Now, if you'll recall, I mentioned that the first message you receive from the WebSocket is going to be the headers that was embedded in that NCCO. So in our case, that's going to be that translation object. That's our model. So we'll just deserialize that into JSON, or deserialize that JSON that's residing in that buffer into that translation object. And from here, we can actually set up some variables and actually start doing some translation. Like set up the UUID for this class. I'll call this start speech translation engine, which we'll get to in a minute. And then I'll set the language spoken, language translated for this object. So now that we're actually receiving messages on this thing, while the message that we pull off of the WebSocket isn't a closed message, we're going to continually read off of the WebSocket, and we're going to write those messages that we get, which is that audio data, into the input stream. And so the input stream is actually a separate WebSocket that the Windows or the Microsoft Speech SDK is opening up to the Azure Cognitive Services in their backend. And after a set period of time, or when it detects silence, it's actually going to trigger a translation event, which and that's going to be giving you the text of the translation thus far. So WebSockets are two-way. So whenever we actually can write audio back into the call, so we've received the translated text and we've synthesized it into translated speech, we're going to serve it back through the WebSocket. So this bit of code is also running in that same while loop, and it reads out of this concurrent queue and writes those messages back into the call as they're getting translated. So this method, as its name suggests, kicks off of the speech translator. So it sets up the translation configuration for the translator and the speech configuration for the speech synthesizer. And then it actually starts up the translator, and it passes this recognizer recognized event handler to the recognizer's recognized event. And then it starts up the whole thing. So in here, recognizer recognized, we've actually received a bit of speech that's translated between two languages. So we need to extract the translated text from the translation event. Ironically, the key is actually only the language bit of that BCP47 string. So I have to split out the hyphen in here. But essentially, I can index into this translation events translations on IN, which is, or HI, which is Hindi, and I get the string from that. Next, I create the audio for a translated text using the speech synthesizer. We set this up earlier to use that translation language as its language and region. Then I construct the data that we defined in the share project, and this will actually capture all the metadata and the text of our translation event. And then I'll actually go through that hub, so that SignalArt hub we talked to earlier, and I'm going to, for all of its clients, send an asynchronous event, receive translation. That's the name of the event, and I'm going to pass the translation result through. And then finally, I'm going to actually take the audio data that I got from here, and I'm going to enqueue it into that concurrent queue that I spoke to earlier. And that's going to tell it to actually write that audio data back across the WebSocket so that the other user can hear it. And now that I've actually added all that logic, now we need to kind of handle that phone call. And I've managed a translation. We're going to move on to the final bit of this, which again is ironically the easy part, which is building the front end of the application. So we're going to build an independent component for this time. And that's actually going to show off something that's kind of neat. It's called translation component. We're going to define it in translation component.razor. We'll use that SignalR client library in this shared project, and the shared project in this. And then we're going to also inject a navigation manager object, which will help us route all this through our hubs. And finally, because we're going to be building a hub connection, we're also going to need to implement iDisposable because it needs to be cleaned up afterwards. So we'll just need to add, I'm just going to add a simple table to hold all the translations. There's nothing special going on here. If you remember the table that I used for the inbound messages earlier, very similar. Except in this case, I'm using a dictionary to hold the translations, and it's going to become inherently obvious why I'm using a dictionary instead of a list in a moment. But I'm using a dictionary, and I'm pushing all those same fields out. So this is the uninitialized async method. So this is a lifecycle event in Blazor that's called when the component finishes initializing. And so this is actually going to be kind of where all the logic needs to be in our component. So the first thing we're going to do is build a hub connection. We need to tie it back to that. You'll see that /translation hub route that we spoke to earlier. It's just getting the full URI from the navigation manager to /translation hub. And then we do a dot build to build the whole hub connection. And then in that hub connection, we're going to register to that same receive translation event that we were pushing all of our messages through. So our translation messages through. Sorry. And this is actually like, I stopped earlier to talk a bit to kind of reflect on like how easy it was to make an HTTP request. If any of you have used SignalR with JavaScript, you probably remember that it's not particularly straightforward to use, but because of the way Blazor is constructed, like it's become really very simple because we have these strongly typed objects. And we can like tightly couple them to our shared data. We can actually like translate. We can receive the same message in our Blazor front end that we're sending from our back end, and actually kind of have everything synchronized. So like, I hate to keep harping on this, but like it's super cool that we're able to do this, and it's made things a lot easier. When I was working on the air traffic control system for the UK and the US, we used SignalR in our network manager, and I mean, like we used to call it like the demon magic part of the application because no one kind of understood how it worked. But like being able to use it so simply in here is just, for me at least, really exciting. No. Sorry, my wife is yelling at the dog. No. Now with that translation, so now I'm going to come back into like the actual application flow here. So if the translation is one that we're already working off of, we're just going to update the translated text using like the text that we got from the new event. And otherwise, we're just going to take that translation. We're going to add that new translation into our list of translations. And then finally, we're going to call this other lifecycle event in here, state has changed. So like when things change and that you need to change the rendering on from your component, it's a good idea to call this lifecycle event because that's going to tell the renderer to come back in and change the rendering of everything. And then finally, outside of that event definition, we're going to await the start of the hub connection. We're just going to start it up. Also, off of this, outside of this method, there's an iDispose method, which just kind of discards the hub connection as the component winds down. And then finally, in the index.razor file, I'm just going to add this. I've created this component now, this translation component. I'm going to add this tag into the index.razor file, and that component is just going to be rendered in there. So yeah, I mean, like, hold on, let me just show you this, and that's pretty much it. Oh yeah, let me start the app first. You know, before I was when I was setting up for this talk, this is the only app that I didn't validate when I was setting up before. I tested this yesterday, but watch, this is going to be the one that doesn't work.
Always, man. Always.
Let's see if the demo gods are in my favor today. So testing 1 2 3. Oh, there it goes. So hold on. Let's I mean, I don't speak Hindi. So I don't know if anybody on this call does. I know you all are in India, but I mean, if this makes any sense to you. But like it's essentially taking my voice and it's translating into Hindi and it's rendering on this page, which is I think is pretty cool. Like you could see just how reactive these applications are.
It's pretty slick.
So, all right. And I mean, we just and I'm just now remembering what I forgot to do today. So, I mean, I hope you all enjoyed this little discussion about Blazor. I have to admit, I'm really excited to see what's coming next with this. Like you might have heard it in my inflection throughout this talk, but like I'm really quite taken with this new framework and this because I've never been much of a front end person. I've always been like more of a back end dev, but it's really cool to see that you can actually build all your front end code in Blazor. So before I go, I just want to kind of tell you a little bit more about me. So I've been a developer for about 7 years now. I've been a .NET developer for virtually all that time. So I'm the .NET developer advocate at Vonage, like I said earlier. I've got my start working on the global positioning system and the American and UK air traffic control systems before I moved into advocacy. On my nights and weekends, I study computer perception and robotics at Georgia Tech, go Yellow Jackets, and I'm also a graduate assistant there. I'm helping instruct a class in essentially building machine learning models for stock market strategies and stuff like that. So if you're interested in following my work, you can follow me on my blog at slorello.com. You can follow me on Twitter at slorello. Yeah. I just want to tell you all a little bit more about my company before I go. I actually, what I forgot to do today was update this coupon code. We do have a new coupon code, which you can ping me on Twitter if you're curious. If you're curious to try. But yeah, we provide all sorts of communication APIs. As you saw, we have WhatsApp, SMS, Facebook Messenger, Viber. We have a really rich voice API. We have pretty much a market-leading video API. You might have heard of it. It's the Vonage video API now, but originally was branded as OpenTalk. So if any of you have heard of OpenTalk before. But yeah, if you need to talk to your customers, come talk to us. You could visit us at developer.nextway.com. Come check out our stuff. So here's some resources. All of the demos I showed you today are in these 3 GitHub repos up here. If you need to learn more about Blazor, I would always recommend going to docs.microsoft.com because they have a tremendous amount of content. Also, if you tweet something with #Blazor or question, someone will probably get back to you because the Blazor is really huge in the .NET Twitter universe right now. So yeah, does anybody have any questions? Let me see if there's any questions in the chat.
I'm good, man. Thank you for that. That was really good.
Hey, thank you, Steve, for the great presentation.
No problem.